Welcome, geeks. Happy 2021, and welcome to the first show of the second season of Rockin The Code World with dotNetDave. I'm really glad you're here. It's a pretty crazy time in America right now, and I need a distraction. So I'm glad we're back. Got a great guest. We got great guests all this month, and I'm already working on next month too. So I'm excited about what's coming up for the show this year so far. So anyway, today we have Richard Lander from Microsoft. I've known him for a few years now, and it's going to be great to talk with him because he works a lot on the .NET runtime. So get your questions ready and start posting them, and so we can ask Richard all those tough questions about the runtime. So anyway, so let's get going. So it's 2021, and my conference tour this year is called For Those About the Code Worldwide Tour 2021. So if any conference organizers out there want me to speak at their conference this year, virtually for now, but as soon as I get the shot, I'll do it in person. And so go to that URL and you can request me to speak this year. I'm looking forward to it. I know I'll be on C# Corner a lot this year too. So go to that link if you want me to speak this year. I'll speak anywhere pretty much, especially virtually. So also, I know the holidays are over, but we did a lot of cooking on the holidays. So I hope you will submit some of those recipes to the helloworldcookbook.com. I'm gathering recipes from technical people just like you and I, and going to put it together in a book. And then hopefully this year, get the book out, and then 100% of the proceeds of that book will be donated monthly to the Voice of Slum NGO, which I visited last year in one of the slums in Delhi, India. So please go there. I don't have enough Indian recipes, so come on. I need more. I love Indian food. So we have giveaways this week, just like every week recently. Everybody wins a copy of Code Rush from DevExpress, my favorite code refactoring tool. And then at the end of the show, we'll give away some C# Corner swag. And how do you win? Just pay attention and have fast fingers. And the first person that answers the question gets the C# Corner stuff. So I have a brand new article on C# Corner for the year. This is my first one for the year. It's called Analyzing Code for Issues in .NET 5. And I'm not only bringing it up because I hope this article helps you out, but also I just got this yesterday, the proof copy of the book you see in the tweet. And it's my 7th edition of my coding standards book there. See if I can figure out how I can do it right. There you go. The 7th edition of my coding standards book. And it is the biggest book I've ever self-published. It's over 330 pages. When the package came yesterday, I picked it up and I go, man, they must have shipped me multiple books, but I only ordered one. And then when I opened it, there was one in it. I was going, oh my gosh, this thing is heavy. So as soon as I approve this weekend, you can start getting it on Amazon.com. Right now, if you want an autographed copy, you can go to my website and order that right now. And some people have done that already. So everybody who's pre-ordered one, thank you very much. And as soon as I get them in, I'll be shipping them to you probably later this month. All right. So the first giveaway, everybody gets a copy of Code Rush from DevExpress. Code Rush is the only refactoring tool I've ever used in Visual Studio. I love it. It really helps me be productive. And I would only recommend it because I really love the tool. And I really, every day that I code, I have to use Code Rush. So if you go to devexpress.com/dotnetdave, you can get your own real copy, not a trial copy or limited time copy, real copy of Code Rush from DevExpress. So I want to thank DevExpress and our Mark Miller for providing this to all of my viewers. So thanks. And with that, I'm going to introduce my guest for this this first show of the year. Richard Lander is a principal program manager on the .NET team at Microsoft. He works on making .NET work great in the cloud, in memory-limited Docker containers, and I want to find out what those are, and on ARM hardware like Raspberry Pi. He is part of the design team that defines new .NET runtime capabilities and features. So welcome, Richard.
Hello. Yeah, thank you. That's
How's
a
it
great
going?
introduction. Yeah, awesome.
You
All
live in
things
Seattle.
considered.
You live in Seattle area, don't you?
Yeah. I live about 20-minute bike ride from main campus.
Oh, that's right. You love the bike ride.
Yep.
I forgot. Yeah. So how's the weather going up there right now?
If I look out my window right now, I can't see very far, so it's very very foggy.
Well, I won't make you jealous by telling you what the weather is down here. So,
Yeah, I'm sure.
Well, I'm glad you're on the show, especially the first show of the year, and you know, you gave me some things to talk about, and we could probably talk about those for hours, but I do want to start off with a question that someone asked from Twitter. So anybody, you know, if I have a guest on or a future guest on, please pre-email me your questions on Twitter, and then I can get them to the guest and we can talk about them on the show. So here's the first one from Twitter. One of the most significant changes to the CLR was the introduction of generics about 17 years ago. What does the next 20 years look like for the CLR?
Yeah, so I agree with the baseline assumption that generics was probably, or it was one of the most significant changes.
Yeah.
And, you know, so we should pause there for a sec. So it's going to be a bit of a long answer.
That's okay. We have until 11 o'clock. So
yeah. So I think, you know, one thing to clarify is this is the way .NET generics work is different than, say, the way Java generics works. So they're sometimes called reified generics, which means that they're both a compile time and a runtime concept. Whereas with Java, they're just a runtime concept. Sorry, compile time, and the runtime largely doesn't know about them. And so it means that every bit of .NET software, be it a compile time thing or a runtime thing, they deal with generics in the same way. And generics have 100% fidelity no matter where you use them. And that has ended up being quite powerful. So anyway, I just wanted to touch on that. So this is kind of like a three-part answer. That was the first part. Second part is like a lot of the programmability features in .NET are come out of the C# design team, which we call the LDM at Microsoft, which is I think it just stands for Language Design Meeting, but we call it C# LDM, and it's a meeting that I think happens on like Tuesdays at 10 o'clock for 2 hours. And it's been like that for like 20 years. So, you know, and a lot of the same people have gone there the whole time. And so features like generics, link, async await, and others have come out of that group. And so I'm not on that group. I don't deserve to be on that group. I don't have really the skill set for that particular meeting. So I guess the reason I'm bringing that up is, you know, I hear bits and pieces of what it is they're working on. And so as it relates to, you know, people watching the show and who like really like generics, it might be something that comes out of the C# LDM that they really like, you know, that they, once we get to like 2025 or 2027, you know, they look back and say like, oh, that's the big new one. And it's something that they built. So you know, and I'm certainly hopeful that that's the truth. Actually, I'd love it if the best new features came out of LDM and not out of my team, because I think they're the most likely to be, you know, super powerful. Now, that all said, the absolute best features that we've ever built, even though they may have started in LDM, in the C# LDM, they are full stack features. So they need a little bit of runtime help, you know, a little bit, sometimes a lot of base class libraries help, and often a bunch of Visual Studio help. And so this is where, you know, the kernel of a really good idea from C# LDM actually gets kind of augmented and polished by these other folks who work on other parts of the product. And, you know, all the ones I mentioned, generic, link, little less so on link, but generics and certainly async await were full stack features that got a lot of, you know, polish and different points of view that were incorporated in the final features. Okay, so in terms of runtime innovation, you know, looking forward, you know, let's see. I actually wrote down some notes on this, so I'm just looking at what I thought. I might skip all that. I think I said all that already. Anyway, so yeah, so in terms of the product, like there's these fundamentals, which are like type and memory safety, garbage collection. Those are things the .NET is known for. I suspect those are not going to change in fundamental ways. Like we're going to keep those aspects of the product, I won't say as is, but like in theory, they will be the same. So there are places where we see that those could be improved, and garbage collection would probably be top of the list. But on the very core of the product, that will probably remain kind of constant. And so if I look at what we have in mind for the future, three things kind of came to mind for me. And this is now I'm kind of really getting to answers to the question. One was this idea, and Jan Kodas from our team wrote this doc, which we can provide the link to, called .NET Form Factors. And right now, we really only satisfy one form factor, which is kind of this generic general purpose dynamic runtime. And, you know, we've definitely flirted with some other form factors. Like, for example, we have this like native .NET runtime that we've offered for UWP, and we haven't offered it for anything else. And it's actually got some really impressive technology that is part of it. And it's really easy to see how that could be useful for the cloud, for example. Now, it also, the part of the reason we haven't extended it to other places is because it has many characteristics that are not like .NET, not like the rest of .NET, which is a fragmentation problem. So the problem, the topic we're actually working on right now, one of the things is making it so that we can have multiple form factors and not fragment the platform. Which is a tough nut to crack. So I have three things. That's the first one, is covering more form factors, making them kind of best in class or very close to best in class, with the right characteristics, yet not for fragmenting the platform. The second one is around interop. So native interop has actually always been a strong point of .NET. You know, again, this is like the native interop we have is quite different than something like Java, again, to mention that one. And the reason it, like the features that makes it like that are like user-defined value types, native function pointers, and what was another one that I thought of? I'm missing an obvious one. It'll come to me in a moment. Anyway, so I think what you'll see is like if you watch our repos closely, you'll see that we removed WinRT interop from the product, and that actually forced us to expose low-level APIs that were not public on in the libraries, so that people could write a tool. I mean, it was another team at Microsoft that was doing that, but that's somewhat irrelevant because the APIs we expose and will continue to expand could be used for anything. So I think you'll see us focus more on native interop across multiple operating systems with a tool-based approach, much like we did with WinRT. We'll probably end up doing that with COM interop as well. We're actually looking at Mac OS right now with a native interop solution there. And then we'll probably expand that to like language platform interop. So, you know, you might see us have a tool-based approach, much like Xamarin has, but it'll be a little different, so that you can call into like Objective-C or Java code or something like that. And so like, and kind of a reflection on that is, you know, .NET was definitely not first to the game with like big data in the 2000s. That was Java, or AI and ML in the 2010s. That was Python. And, you know, maybe .NET's going to be the next one who's going to be the leader in some domain, but maybe not. And if we have first-class language interop, then it kind of matters a whole lot less that the stack, the you know, dominant stack, like functional stack of the day is built on something else. And then what was my last one of the three?
Oh, can I pause right there? So do
Yeah.
you get a lot of requests for the language interop? You must if it's on your radar.
Yeah, the Java one is probably the #1 on the list. You know, it comes down to people want to have, like, a lot of people have a primary programming language, whatever it is. But then they often want to use components from another system. And, you know, this goes to what I was saying earlier, which is, you know, Java was clearly the leader in big data, like Hadoop and that kind of thing. So there's definitely C# programmers that want to use jars. And you know, like I got a request actually already this year from someone saying they wanted the other direction. They say they have a lot of C# code, but they want to use it from their Java apps. So, you know, mix and match. You know, I think mix and match is totally legit.
Well, even in, you know, that was one of the, you know, if you go all the way back to the beginning of .NET, you know, that was always one of the things, especially in the beginning, that made it attractive, is that, you know, you could talk to other, you know, languages from .NET, you know, and you know, and .NET made it both ways, right? And
yeah, that was more though.
That was the interop
DLLs
DLLs
that ran on top of the CLR, the you know, common language runtime. You know, so like Java and Python, they don't run on top, or Objective-C, they don't run on top. They're separate. You know, that could have been a different strategy. I think it's a failing strategy, but is try and build bridges so that we can kind of run, say, Java on top, like, you know, IKVM does that, run Java on top of the runtime, and then kind of go that path. You know, I think for some scenarios that totally makes sense. So like, for example, you can run Minecraft that way. And, you know, Minecraft is an app. And so it's a closed universe. It kind of wouldn't work for something like Android interop, because Android is like the operating system in that case. So you can't kind of like, and it's multi-process, and that approach will kind of fall down pretty quickly, in my opinion. So so my last thing was actually around programming safety. So this one might be a little farther afield for some people, but you know, when we started out .NET, type safety and memory safety were kind of, you know, super high on the list of you know, core features, and as I suggested earlier, that's remains the case and isn't changing, so no one needs to get worried. But I guess there are some parts of the platform that have never been like completely awesome. So like, for example, ownership is an example of that. So like iDisposable isn't necessarily a super amazing system. Another thing is that we've actually started to build features in safe code that are not quite as safe as we would like. Like some of them have these performance trade-offs. So span and memory of T are an example. Array pooling is another example. And so this is another one of those tough nut to crack issues where we need to come up with models where we don't have to have like as pernicious trade-offs on performance and safety as we currently have. So I think, one way to think about that is like just to define safety for people. Like we don't really have like security problems per se,
right?
Like because that's what the lack of safety can lead to. So like, for example, we have all this code in the product and the code is super heavily scrutinized. So we're using humans for some of our safety issues. And obviously some stuff can get through and does, and then we patch it. And most of the code of that type of code is written by experts. We'd like to get to a model where more people can safely use some of these newer kind of more low-level features, get very high performance, and get diagnostics that tell them, yeah, don't do that. That's not the safe way. So that's kind of a last thing. I guess the only other thing to mention is our GC team kind of has used the same model for the GC for like more or less since the beginning. It's definitely improved a lot. Like it's probably like 10 times better than when it started, but model wise, it's very similar,
right,
to where it was.
Hasn't changed much.
Yeah, and so like model wise, it has changed a lot technically. But I guess what I'm saying is I don't feel like the current model has exactly topped out, but at the same time, it's time to think of some kind of like a new approach. And the team's been doing that for at least the last 2 years. And so I feel like definitely within the first half of 2020, you'll see some pretty dramatic changes to the GC to help it scale, both with respect to very large machines. Like, it won't be that far off, and we're going to have machines with 0.5 terabyte of memory. It's not like we're already at the place where we're pushing 0.25 terabyte of memory on the biggest machine. So that's one type of scaling. The other type of scaling is scaling from something like an Apple Watch all the way up to that 0.5 terabyte machine, potentially with the same GC, at least from a code-based perspective. So that's kind of my last one. So those are my thoughts on what we can see in the next 20 years. Sorry, that was such a long answer.
No, it's good. And I would have guessed that, making sure that, the GC works well, like with microservices, and Azure functions and stuff is hopefully a priority too, because those are another kind of thing that just quickly spins up and spins down. And so.
Absolutely. I agree. Actually, I'm looking at my notes. I see Jan actually asked me to talk about something else too, which was source generators. So source generators is a new feature in .NET 5. And, Jan's take on this was right now, whenever we want to do some important bit of innovation, we have to add the feature to the C# compiler. C# compiler often has to generate a bunch of code that it injects into your assembly. Async await would be a perfect example of where it's doing that, but there are plenty of other features where it does that. And with source generators, we could potentially start building like whole new features through that. And not necessarily have to like add them directly to the compiler. They might be actually easier to change in version because they might be NuGet packages. And so there's this like brave new world that might be possible with source generators that, totally wasn't possible before.
So I haven't really looked into the source generators. Is that kind of like what happened when we did, because I really love this, but it's gone now, when we did code contracts? Is that kind of the same?
I don't think so.
No, it's different.
So I'm not an expert on code contracts, but my understanding is, you had these attributes, typically on top of methods.
Then to inject the code into the compiled assembly.
Yeah, so I guess that was way more narrow than source generators. So source generators can, and then that was focused on kind of a diagnostic, contract model. Source generators are completely open-ended. So like whatever code you want to generate for whatever reason, you can.
But you could like do a new code contracts with.
Yeah, you totally could do a code contract system with that. Like you could actually even respect those exact same attributes that were there before.
You're giving me an idea.
Yeah, no,
because I love code contracts. I'm really sad they're gone. They were, a great way to do some things that are quite difficult if you don't do something like that. But
actually, so I just looked at my notes. The native interop features that I couldn't remember that I had written down before were user-defined value types, which I mentioned, span of T, which I didn't mention, native function pointers, which I did mention, and then the new pin GC heap. Because with interop, if you use something like span of T, what you're basically saying is, I'm going to overlay this span on top of native memory that someone else owns. Then actually, that's a bad example. It would be the opposite direction. I'm going to create this memory on the managed side and then expose it to native code. And then I own it. And then it's going to use it. Now, the GC likes to do this, it does mark and sweep, and then it compacts. And so it moves your memory. Well, if you've given out this memory to some other system, then it's, you're going to actually give like memory addresses. And so the system isn't tolerant to that memory being moved. So we've had pinning for ages. But in .NET 5, we now make it so that pin memory goes into its own heap, which means that the pin memory doesn't, what's the word, like subvert isn't the right word. It doesn't make the regular GC memory worse. So all the pin memory is somewhere else. It kind of does its own crazy thing. And then regular memory cannot do the whole compact thing. And then it limits the amount of fragmentation that we have in memory. And then the whole system works a ton better. So I think all those features are really picture perfect for interop with other systems, those ones I mentioned.
Yeah, I've dealt with the pin memory too when I'm doing memory profiling on apps, and I see that. So yeah, it will be great to see that. And then new changes where you can put it off in some other heap or something, or some other area. Yeah.
No, you said the right thing.
Yeah. So we don't have any more questions. Come on, everybody, got to ask questions. So, can you explain to me, because I haven't heard this yet, is the memory limited Docker containers?
Oh yeah, you said that in the intro. Yeah. It's not as fancy and interesting as you might think, but I will endeavor to tell you. So let's talk about what Docker containers are to start with. So there's kind of two different ways of thinking about them. One is they're like a very small virtual machine. And, the Docker file is kind of like the recipe for it, for what you want this virtual machine to be. And then you like type Docker build, and then it like goes and gets, say, like Debian Linux and a bunch of packages from out in the internet. And then you have this Docker image, which then you can either share with others or you can boot up on your machine, and you have that kind of this virtual VM. It's not actually a VM. Some people are going to hate that I even use that term, but I think that's one way of thinking about it. The second way, and this is the one that's kind of going to answer the question, is it's definitely not a VM at all. It's a super isolated process on the machine, meaning it is actually a process. Well, it could be multiple, but it's basically, let's stick with one process. It's a process that has a very different set of characteristics. So one is it's got like basically no privileges to the rest of the machine. Yeah, that's the main one. And like its whole networking setup is often quite different. And then the important one is there's this system in Linux, and I'll tell you what the one is in Windows in a sec. It's called C groups. And C groups, one of the aspects of it is that you can specify how much CPU time this Docker container should get and how much memory it should get access to. And there are tons of other settings. In Windows, it's called job objects that does more or less the same thing. And so when you on your machine, like on a developer machine, if you have Docker Desktop installed, it actually defaults to 2 CPUs. And I think it gives you access to all the memory on the machine, if I'm not incorrect. But you can specify a different set of CPUs. Actually, I think you can't go higher than the 2 CPUs unless you set Docker Desktop to see more, but I'm ignoring that particular problem for a sec because I don't know what the answer to that question is. But let's stick with memory. You can specify like -M 100 MB. And then that means that this process is only going to get access to 100 megabytes of memory on the machine. If it goes past 100 megabytes, it gets what's called killed. So out of memory killed. And your process will literally just die. There's no unhandled exception that you can catch to deal with this, because the is well outside of the .NET runtime. This is this is in like the C group system. So there's definitely no callback that you can kind of manage. And so like a bunch of the work we've done is making sure that like the way that the GC works in containers, like it knows what this number is, like say 100 megabytes. The number can be lower than that, but I just picked that because it's a round number. And it knows what that number is. It creates its GC heap in terms of that, so smaller, and it tries to garbage collect such that it keeps you in a good place, such that you hopefully don't hit that number. And so we put our changes for that went into .NET Core 3.0. So that's kind of when things got good. I'm hoping we're actually going to take another run at this in 6.0 to make it even more sophisticated. But the product is pretty good on this front since 3.0.
Cool.
And like pretty much all Kubernetes clusters run with both memory and CPU limits.
Cool. Yeah.
So it's very common.
Yeah, unfortunately, I haven't been able to really use Docker that much because no company I work for seems to want to use it. So, but someday I hope to use it some more. And
yeah, it's also really good. Like, one of the ways we use it is if you just want to try, say you have a Windows machine or a Mac.
Yeah, and you want to demo stuff. Yeah.
Or not even demo stuff, but you want to like try something, like do some like, oh, I wonder how this works on Linux. You can just boot up a Docker container in no time at all. And, you can either just run the code or you can boot into it interactively. Yeah. And we do this a lot. It's just the super cheapest way to get a Linux command prompt.
And you could sell Docker containers now too, right? I think on their site.
Yes, you can. Yeah. You can. We don't do that, so I know
you guys don't.
Any experience in that domain, but yes, that is a thing.
Yeah. I just thought about it before about putting like all of my coding standard stuff and all that stuff on a Docker container, and maybe a copy of the book, and then sell that. I don't know. It's crazy ideas I think of sometimes. I've never.
Yeah, I don't know.
So. I was looking at, so do you want to see how many, do you want to talk a little bit about, because I'm curious about this too, is just, .NET working on ARM and the Raspberry Pi?
Sure.
I don't follow that a lot because, I do mostly, business, coding for business work. So I don't follow that a lot, but it's,
Yeah.
I know a lot of people are using it.
Yeah. So there's a couple different pieces to that. When I think of Raspberry Pi and things like it, I think of maybe it's a list of 3 things. One is, it's primarily Linux. So, you need to have good Linux support. The second one is they're all ARM machines,
Mhm.
which you mentioned. So you need to have good ARM support. And then the last one is, these Raspberry Pis. I've got this they're all hooked up at the moment. They all have these pins on them, and they're all hooked up, even though they're really close to me. So they all have these pins on them. This isn't a Raspberry Pi, but these are pins in any case. So these are what pins look like. I'm going to focus on talking. Now I lost my train. Oh, yes. So there are all these pins, then they're all electrical. They're actually digital, but that's somewhat irrelevant. And you need a system to be able to program them. Either, you're trying to drive something like lights, like LEDs, or you're trying to or servos, you're trying to make something move. Or you're trying to pull data out of something like a sensor, like a temperature sensor or something like that, or a light sensor. So then you need a programmability system to do all those things I just mentioned. We kind of call those GPIO APIs. There's a whole bunch of other protocols as well that we support, like SPI, blah, blah, blah. But I just say GPIO because it's and GPIO stands for General Purpose In-Out. It's not a very fancy acronym. So, the Linux support we've been working on for years, since .NET Core 1.0. So there's nothing particularly special about Raspberry Pi as it relates to that. Raspbian is a Debian-based operating system. That's why it's called Bian, because it's Debian. So that part, nothing particularly special there. The ARM support is, we added along the way. Although we've had ARM implementations for a very long time. The first ARM implementation I think we did was for Windows Phone. And so we kept a bunch of that code. So we started with ARM32. We now have ARM64 as well. So on that front, just so people know, the Raspberry Pi 2 is ARM32 only. The Raspberry Pi 3 and later they're ARM64 chips. Raspbian is a 32-bit OS currently. So when you install it, even on an ARM64 chip, you're running in 32-bit mode, much like it was in the Windows space back 15 or so years ago, where you
Windows
might find
under Windows, or
no, that's not the part I'm talking about. I was talking about for a while there, you might buy a machine from Dell that actually had a 64-bit chip in it, but they actually sold a 32-bit operating system on it. It's like that.
Yeah.
So, we've been slowly adding ARM support. At first, it was just purely functional. If you look at our blog posts from .NET 5, we did a ton of performance work for ARM64. So now we actually have a very capable ARM64 implementation that we're pretty proud of. We're actually not going to do that same performance work for ARM32. So we see ARM64 as the future. Clearly, Apple thinks so too. Their new laptops are ARM64. Then the last one is this. We have 2 NuGet packages. One is system.device.gpio, and it includes all the base APIs you need to use the common serial protocols on Raspberry Pi and similar devices. And then we have another one called IoT.device.bindings, and it includes a ton of bindings actually for little devices like this. And for You know, it allows you to use these kinds of things. I got tons of stuff on my desk. This is a Sense hat.
Wow.
Yeah, we have a binding for this. So like, because if we didn't have the bindings, you'd have to use these GPIO and similar types of APIs directly, and then you have to like figure out what this thing even wants, which actually is not super. Like, you have to read a spec sheet that says like how this thing even works. Whereas like someone has built up a binding, most of them have come from the community, and it just like offers you a super intuitive API that it's like within 10 minutes you can know how to like light up this grid.
Wow.
And then like we have APIs such that like not only can you like light up each one of these cells or these LEDs, it will allow you to like write text across this. So like that's how high level we have kind of gotten with these things. So yeah, so that's what we've been doing. And I think, you know, the nice thing is that like the last thing I mentioned, like GPIO, that's very specific to, you know, the IoT Raspberry Pi space. But like all the work that we do on Linux and in ARM64 for other things just comes here for free. Like, you know, and since, you know, ARM64 is getting more popular, so like right now we're doing a project to add support for the Apple M1 chip, as you can imagine. Otherwise we'd have to drop support for macOS, which we have no interest in doing. And so there's a bunch of new work that we're doing for ARM64 that's not unique to Apple, but Apple's the only one who currently requires it. And so when we get that work done, it means like ARM64, Linux, and Windows machines will also benefit from those investments. So yeah, I guess two birds, one stone kind of deal.
That's cool. You know, I've always been interested in playing around with the Raspberry Pi, but you've given me a great idea, because someone asked me, you know, on the holiday break, because I was asking people about 3D printers, and they said, well, what do you want to do? And I go, I don't know. I haven't figured that out yet. But you just reminded me of the project I wanted to do way back when Raspberry Pis came out. And that is, you know, when I go to conferences, you know, I throw out guitar picks and stuff like that to people. I have custom guitar picks I throw out, and, you know, and so I always wanted to make like a custom guitar pick launcher, you know, that would just sit there and launch guitar picks while I'm talking, you know.
Yeah. Although you could also design guitar picks.
Well, that too. Yeah. But I have these custom ones made by the only guitar picks I use is from a company called Clayton Guitar Picks. And
wow.
So I actually get them custom made. And so for like on one side is, you know, me, like a picture of me or something, and my URL, and the other side is I get somebody like Grape City to pay for the guitar pick, so their logo goes on the other side. So
sounds like a good deal to me.
Yeah, and I even you know, a few years back I got to play at my favorite music venue in San Diego. It's called the Belly Up. It's just a couple exits up for me in Solana Beach. It's very famous. It's been around since the 70s. But anyway, that was on my bucket list of a place to, you know, one of the places I want to play, you know, before I get too old. And so I got to play there, but I threw those guitar picks out. So I'm sure the people are going, what is this? It's not in a band, you know.
Yeah, anyway. I'm from Toronto. So Massey Hall would be the place to play before you die. For actually for a big band.
Yeah. So that's always fun to do. And actually my guest next week is a guitar player too, so we might geek out all on that. So
sounds perfect.
Yeah. Who knows? Well, I had a guest last month that, you know, builds his own guitars. From scratch, and they're pretty impressive. I haven't actually gotten to play one yet, but I hope to next time I visit LA or next time he's down here or something. But let's see. We only have time for like one more question. And how about, what do you hear from developers? What are the common trends of Microsoft? Have you talked about that a little bit already?
I mean, I think we can do a quick one there, which is, you know, it's super varied. So one set of folks, you know, we hear like, you know, we talk to people on calls and they say, you know, we're moving everything to Docker containers, Kubernetes, doing that thing. So there's a ton of people, you know, we use your Docker images that are on the Microsoft Container Registry. That's very common.
Mm-hmm.
So that's one quite large slice. Now, clearly here I'm talking about the web side, like
Mm-hmm.
server side.
Right.
You know, another set of folks are saying, you know, we have like a bazillion tons of .NET code and, you know, 1,000 apps. And we really don't know where to start in terms of moving it forward.
Mm-hmm.
We don't have that big of a team, and you know, our company's conservative, blah blah blah. And these are like caricature stereotype type things. And you know, those conversations can be a bit hard, just because, you know, we don't know that code base. We give them guidance on how to approach it, and they either do or do not do that.
Right.
Yeah, and with that, yeah. So I guess, you know, it really comes down to two main buckets, maybe, which is folks that are kind of closer towards the bleeding edge. And, you know, clearly even the ones who are on the bleeding edge, they've decided to leave some apps behind on, you know, say, some of them are even still on .NET Framework 3.5.
Yeah.
And, you know, they're pragmatic. And, you know, that all makes sense to me. And then other ones don't have a good plan for moving forward. And while, you know, .NET Framework will be supported for a very, very long time, you know, I think it's important for businesses to figure out how to move their most important apps forward.
Yeah, so I've been trying to recommend that to anybody who will listen to me, the same thing, you know. And you know, if you're still writing new apps in the framework, you know, you should rethink that, you know, right now, and especially with .NET 5 and then, you know, .NET 6 coming out, and I think, you know, finally that, you know, everything's back into one framework basically. I think things will get a little bit better about people understanding and hopefully get better moving forward too, you know.
Let's hope.
Yeah, and I've been, right now I'm working on moving my open source over to .NET 5, and I'm getting close to releasing the first two NuGet packages, and I have to say, so far I've run into, you know, literally not any problems at all moving, you know, from .NET Core to .NET 5. You know, I know framework is a bit different, but at least going that way has been a really easy change, you know, pretty much. And I, you know, I also wanted to say before we leave is, you know, now that I have my, you know, coding standards book finally almost in print, you know, my next target is my performance book, and you know, back in, I think, November, you know, I ran my, you know, performance benchmark test, which takes like literally almost a day to run, and generally across the board, .NET 5 is faster than .NET Core. So you guys did a lot of great, and some of it's significantly faster. And so I'm working on, you know, those benchmarks and stuff for the next version of the book, which I hope to get out next year. I mean, this year, but I just want to say thanks for all the great work, you know, because I'm so much into performance and all that kind of stuff. So you guys done a great job.
Yeah, I you know, so I think the release is good, just right, like you said, but you know, like we've got a great team with a great culture, and you know, almost the entire .NET 5 release was done during the pandemic. So we had to transition, and then obviously my team is not unique in that respect, but I was super happy that the team was able to rally. We were able to do much of what we had first intended to do, and we were able to make our original date, which was November. That was really never called into question. We have a kind of a mentality which is cut to ship. And so we did that. We did cut some features along the way to make the date and make the quality level that we needed. But I'm really proud of the team, and I think that they really came through in a really difficult situation.
That's because I know a lot of, I wrote a series of articles on C# Corner last year about the benefits of working remote, and how I've been doing remote work for 8 straight years now, and so now that everybody is forced to work from home at Microsoft, do you feel your team is more productive, about the same? Because you did get it out on time, so.
I guess 2 thoughts on that. One is, Hanselman did a post at some point, let's just say June, I'm totally making that up, that, quarantine work is not remote work, or like it's different. And while I wasn't a remote worker before, I suspect that he's right. He is a remote worker, so I'm going to trust him on that one. So, the stresses are very different. But the second point is, I think working remotely is just different. It's not exactly better or worse. Like, one thing I noticed is like, we have these team rooms, and I was lucky to be in a 4-person kind of desk area with like 4 people that I, absolutely, it's kind of a weird word to use, but I'm gonna use it anyway, that I absolutely adore. I think they're amazing. So that you kind of get a bit of a cliques forming just by virtue of where you're sitting. And then when you're in remote, that like those locations erase. Now, clearly I relied super heavily on my network that I, people that I'm used to working with and all those kinds of things. But it meant that like there were some people I probably should have been working more with in the past that during remote period I did work more with, because I wasn't influenced by the building anymore. So that was one difference I noted.
Yeah, what you said kind of reminded me of because even though I work at home alone most of the time, a couple of years ago, I went and did, because I'm a photographer, and I work for a lot of rock bands and stuff like that. But my daughter-in-law invited me to come do photography for the Austin Film Festival, because she was like the number 2 person there. And so I, for the first time was able to do a film festival, and got to meet a lot of, famous directors and actors and producers and all these kind of people. And I remember just sitting in those rooms, just feeling the creativity being bombarded at me, right? Because I'm in these rooms with these ultra creative people, and I could feel it, and it kind of made me feel better, and it helped me turn on my creative juices and stuff. So,
yeah, actually, I think that's a really good point, because like, when I was in the room, and actually the room I was in had like most of the C# LDM in it that I mentioned before. So really, really great, smart people. And so I always felt like this energy around me. It's like, clearly I need to be at the top of my game to even talk to these people. And when you're at home, particularly if you're in a room by yourself, you have to kind of do something extra to recreate that environment to have that feeling that you're both, part of something, but also to like get those creative energies from others to kind of go across the wires.
Yeah. It's tough. Yeah.
Yeah.
Well, we got to wrap it up. I only have a few minutes left. So
Yeah.
I really appreciate you being on the show and being the first guest on my show for 2021. I'm glad I got you on, and if you want to hang out afterwards, we can chat a little bit. And
Sure.
We didn't get to talking about biking or anything, but maybe next time after the dotNet 6 comes out, we can have you on again and chat. All right. Well, thanks a lot, and I have a great, safe weekend, and safe until you get the shot, right? So
yeah, for sure. Thank you.
All right. Thanks a lot, Richard. Well, that was an awesome interview. He's Richard, is one of those guys where I'm going to have to go back and watch my own show, because he had a lot of information, and I don't think I got all of it while he was talking. I don't like watching my own shows, but I think I'm going to have to watch this one. So I really thank Richard for coming on the show. All right. So we got the C# Corner gift. I made it really easy. Hopefully really easy. It'll be easy, especially if you've read or used dotNet 5, because I have to do it dotNet 5. And first person that answers it in the chat will get the C# Corner package. Ready? What is the new class type in dotNet 5? I added the sound. I hope you guys can hear it. That's me playing the Jeopardy song on guitar. Nobody? Okay. Well, if someone answers before the end of the show, they'll be picked and put up on the screen. Okay. There's a new class type in dotNet 5. Google it. All right. Well, thanks for watching, everybody. Next week, I have Brady Gaster, program manager for the developer division at Microsoft. He also is a musician. So like I said earlier, who knows what we're going to be talking about. And Sean, yes, you won. So C# Corner will contact you and get you those gifts. So anyway, next Saturday, this who we have on all this month. I have Microsoft people and into next month too. So if you want to be on the show, please email me, and I'll try to get you on. And you can get a cool shirt just for being on the show. Isn't that awesome? Please be safe out there. COVID is crazy in America. It's worse than the last time I talked to you. Where the last day we had like 4,000 people dead in one day. So no matter where you are in the world, please stay safe. Wear your mask. Listen to your medical science professionals, and so we can get through this all together, and until we get a vaccine. So I also encourage you to go donate blood at your local blood bank, no matter where you are. I donated a few weeks ago, and every time I go, I ask them how the donations are going, and they're not going good. They're way down because of COVID. And so they're in dire need of your blood. So please go donate blood. It doesn't cost a dime, and it will make you feel really good for helping your fellow human throughout get out of this crisis, or even do it in the future. I've been doing it most of my life. So I'm almost up to 12 gallons donated now. So anyway, please do that. Please be safe. Please email me with any suggestions or questions, and I'll see you next Saturday on Rockin The Code World with dotNetDave.